Meet our group. Project task 1. Task 2. Task 3. Problems. Process 1. Conducting meeting.
Bagi dia tu, kita kena tukar data depan kan. Apa cara kita nak masukkan dia? Okay. Lepas tu nanti kita nak
Process 2. Capturing photos together. Process 4. Explaining result.
For task 1 step 1, we are required to snap a photo of our group members in our best pose. This will be our original image. Step 2, we are to visualize our original image into frequency domain using fast Fourier transform and then reconstruct the image to its real domain. So in the MATLAB coding, for the first command we will use clear all and close all. This will clear the command window in the workspace. Next is to read the image by using imData. This is a variable that will store the image data after it's read by imRead. imRead is to read an image file. This is the path to the image file we want to read. In this case, the file is named as signals and is located in the downloads file folder under users/user. Next is to create a new figure window. And then we display the original image. In the results, we will have 6 plots. So the original image will be placed in the first photo of the second row, 2 rows and 3 columns. And then we convert the image to grayscale by using the function RGB to gray. After we convert the image to grayscale, we display the image in the second plot. Next, we get the Fourier transform of the image by using the function FFT2. And then after we get the Fourier transform, we display it again in the third plot. Next is to get the centered spectrum by using the function FSH. And then we display the Fourier transform centered in the fourth plot. And then we apply the log transform and display the log transformed image in the fifth plot. Lastly is to reconstruct the image and display the reconstructed image in the sixth plot. Task 2 step 1. We are to apply a blur effect on our original image using Gaussian kernel. In the first line, the imRead is called to read an image file. In this case, the file name is signal and is located in the downloads folder under users/user. Since task 2 is required to use the Gaussian kernel, we are going to use the Gaussian filter function. The output of this function is assigned to the variable I, which stands for the image. Next, iBlur1 applies Gaussian blur to the image I using standard deviation of 2. The image Gaussian filter function takes 2 arguments. First is the image to be blurred, and second is the standard deviation. In this case, the standard deviation is 2. For iBlur2, we use standard deviation of 4, and for iBlur3, we use a standard deviation of 8. For the subplot, we use a grid of 3 rows, 3 columns, and for the first subplot, we are going to put the original image, which here you can see the title we put as original image. imShow is used to display the image stored in variable I, which is the original image. And for the second subplot, we're going to use for iBlur1, and the title is going to be smooth image with a sigma equals to 2. Sigma represents the standard deviation used for blurry. And for the function imShow iBlur1 is used to display the image stored in variable iBlur1, which is the standard deviation of 2. And for the subplot number 3, we're going to use the title smooth image with a sigma equals to 4. And then again, Sigma represents the standard deviation used for blurring, and in this case, the standard deviation is 4. And an IM show is used to display the image stored in iBlur2 with the standard deviation of 4. Lastly, for subplot number 4, we're going to use the IM show iBlur3. It is used to display the image stored in iBlur3 with a standard deviation of 8, with the title Smooth Image Sigma equals to 8, and the standard deviation of this is 8. Gaussian filter is an image blur effect for the original image which will be affected by changing the sigma values, which are different standard deviations for x and y directions. This we will also display in the subplot arrangements. First 4 functions are showing we have 4 images which are x1, x2, y1 and y2, and the images filter are the ones that gives the filter effect which is Gaussian. In this function, we will use variable I, which is the original image, and 2 values of the standard deviation, which is x and y. So for the first one, we have I blur x1. This one we will use the x-axis for the standard deviation of 4 and y-axis standard deviation of 3. And for x2, we will use x of 8 and y of 2. And y1, we will use x of 1 and y of 7. And y2, we're going to use x of 1 and y of 8. Subplot 5 gives a blur image for original image. Since standard deviation also equals to sigma, so sigma x is 4 and sigma y axis is 3. Subplot number 6, we will use I blur x2 with a sigma x axis of 8 and a sigma y axis of 2. For subplot number 7, we are using sigma x axis equals to 1 and sigma y axis equals to 7. And lastly, subplot 8, we use sigma x axis of 1 and sigma y axis of 8. And for the last one, this shows a region of interest showing the comparison of an original and smooth image, which results in sky in filtered image. The last subplot shows the comparison of an original image until it becomes a smooth image. So Gaussian filter is just blurring the effect of an original image to a more smoother image. Last but not least is task 3. Task 3 is to detect the edges of your original image using Laplacian of Gaussian, LOG kernel. So in MATLAB, the first line, which is I equals to imread, it means that this line reads an image file named as signal from the specified path, file path users/user/download/signal. The function imread is used to read images into MATLAB. It returns the image data, which is then stored in the variable I. And then subplot 231 creates a subplot with 2 rows, 3 columns, and selects the first subplot for plotting. This means that the subsequent plotting commands will affect this specific subplot. imShow_I. This function displays the image represented by the variable I. imShow is the function used to display images in MATLAB. And then the title, original image, sets the title of the subplot to original image. It labels the image being displayed in the subplot. So in line 4, the h equals to f special log 7 0.4. This line generates a 2D Laplacian of Gaussian LOG filter. The f special function is used to create various types of special filters. In this case, log specifies that we want a Laplacian of Gaussian filter. The parameter 7 and 0.4 indicates the size of the filter and the standard deviation of the Gaussian respectively. I2 equals to imfilter IH. Here the imfilter function is applied to an image I using the filter H that we created in the previous step. This function performs 2D filtering of multidimensional images. It convolves the image I with the filter H. The result is stored in I2. And then in subplot 232, imShow I2, title filter size 7, sigma equals to 0.6. This line creates a subplot with 2 rows and 3 columns, and selects the second subplot for plotting. It then displays the filtered image I2 using imShow and sets the title of the subplot as filter size equals to 7 and then sigma equals to 0.6. The /sigma is a mathematical symbol often used to represent standard deviation. Since task 3 is asked to change the standard deviation value, we're going to change the standard deviation from 0.4 to 0.5 to 0.6, 0.7 and lastly 0.8. So in subplot number 3, it shows a standard deviation for 0.5. In the subplot number 4, it shows with the standard deviation of 0.6. Subplot 5 shows the standard deviation of 0.7. And lastly, subplot number 6 shows the standard deviation of 0.8.
Conclusion.
Thank you for watching this presentation.